Welcome everyone to another episode of the ATX DAO Podcast. Today we have Lukas and Lukas from the Taceo team. So Lukas Squared, welcome to the pod.
Thanks.
Hey, Tom.
Tom, hi.
Awesome. So let's see, as far as diving into Taceo, would love to hear as far as what inspired the vision and the creation of Taceo, and, just give the audience a quick deep dive as far as what problem you guys are ultimately trying to solve in today's blockchain and data landscape.
Yeah, so the motivation of Taceo dates back several years already. A lot of the group that is now forming Taceo was at the research lab in Austria at Graz University of Technology, and we're working on this really fundamental primitives to zero knowledge proofs. One of them was a hash function, which is now the Poseidon hash function, one of the most famous hash functions and primitives in zero knowledge proof systems that are now used for Ethereum, for example, for scalability, or on the other side for privacy. And we saw that early on, this programmable cryptography, how we called that field, has a really huge impact, not only on blockchains, but on the whole internet itself. As for now, we had end-to-end encryption for messaging, but any other app would totally expose all your data. And with this, also creates a lot of economic damage to the user itself. And programmable cryptography is the way to fight back this and get end-to-end encryption, not only for your messaging app, but really for any app that you're using.
So just for our listeners here, you might notice that there's two people from Taceo here. Just wanted to clarify. They're both named Lukas. So this is going to be fun. There's Lukas H and Lukas G. I just wanted to clarify that over here. So if we say Lukas, I guess any one of you can jump in, right? Since both of you are Lukases and both from Taceo. I would love to hear more about, let's take it back to the basis, programmable cryptography, right? Tell me more about that. I'm a golden retriever. Tell me what's so special.
Yeah, I think what's so special about programmable cryptography compared to start with cryptography. What is cryptography? It's this kind of art and science, how to encrypt and decipher messages. So how to kind of keep something confidential from the right persons of people. I have a key, I give you a key, and we are the only two persons really having access to information. Now, this was for the longest time of history, from 2000 years, we had such encryption schemes, but never were we able to really program this. It was only transferring information which you could keep confidential. But now you can, for example, with zero knowledge proofs, a huge technology in the stack of programmable cryptography, you can have something like selective disclosure. So, for example, you could reveal only if there's an age verification, you could only reveal that you're over 18, but not doxing your birthday, for example, that might be used for credit cards or whatever, just for some assurance. So this way, a program, application developer can exactly tailor the amount of information that has to be disclosed.
And I would add, especially in the context of blockchains, there's not really a lot of programmable cryptography right now. So we've seen CK being quite prominent the last couple of years, but I would say that's just the starting point, right? So there are other technologies besides CK, namely MPC or multi-party computation, FAG, we want to put them in that category, which enables basically encrypted compute in an on-chain context. And that's where our motivation comes from, because we see this is kind of a big need in the on-chain space, that we are able to handle sensitive data in some way. But as of today, everything is public, everything is transparent, which is good because we need it for integrity reasons, but it's definitely holding us back to put really sensitive data on chain.
So ZK, zero knowledge, as you mentioned. So you're trying to shift it just from arbitrary fixed function cryptography, right? To be hey, these are arbitrary programs that can be run within these secure containers or these boxes with this new programmable cryptography kind of standard that you guys are you and a lot of people are trying to focus on bringing forward towards Web3 or crypto as a whole, right?
Exactly. the ideal scenario would be like you just like strip something like a programmable cryptography container over your server or whatever, over your blockchain, and like everything is like secure and private. This would be like HTTPS is for the internet. Like you just put this S in front and you know like your connection is end-to-end secure. And this is like what programmable cryptography tries to do with all the computation applications out there.
Okay, cool. So that's what differentiates this from a Web 2 cloud environment to like something like a Web 3 cloud environment, right? You have this specific functionality around these things that are interacting with each other, and you have these secure verification methods through ZK VMs or SNARKs or Starks or parts that you would approach to make sure that in a Web 3 world, you're like, these protocols are saying that mathematically we can prove that these actions are actually occurring. These are the outcomes, these are the inputs, these are the outputs, while making it secure. Right? Just a dummy, succinct version that I'm putting out there. I don't know if that's actually accurate, but is that close enough to being accurate?
I think it already highlights kind of important aspect of how we approach this whole topic, namely combining multiple technologies to actually get to what you just described. Because if you would just run an MPC, multi-party computation, in an off-chain setting and roll back the result to a smart contract, we wouldn't really get verifiability about this computation, because we would need to trust the off-chain component, the off-chain servers, that the computation they performed was actually correct. But if we add CK on top of this MPC computation, we can actually get both. We can get encrypted computation, but also have verifiability and integrity of this compute. And that's kind of the magic if you start combining various technologies in that space and put it together.
Very interesting. So, we'd spoken a bit briefly before we had hit record as far as use cases within, the healthcare space, for example. But I'm curious as far as your thoughts, what industries or sectors do you think the work that Taceo is doing could benefit from Taceo's privacy preserving infrastructure?
Yeah, I think there are a couple of ones. Specific ones we are focusing right now on are, I would say, stablecoin payments. This is still a field which is completely public. Every transaction you perform on-chain is fully transparent and can be seen by everyone. And I don't think there's a world where we have massive stablecoin adoption while all those transactions stay fully public. So we need a way to transact between different parties in a more privacy-preserving way, while also meet all those compliance aspects of it, right? So we had Donator Cash some times ago, realized, okay, that full anonymity and privacy doesn't work out, but also the other extreme of having everything public is not the way to go. So combining privacy with a certain level of compliance, I think that's super interesting for us to solve with those technologies.
And talking to like the really big stakeholders in the stablecoin ecosystem, like everybody will talk, like publicly state, like they're looking into how to make this private. Like it's just like a bit hard on that scale, and because nobody did it on that scale so far, but like everybody wants it.
So this goes to a perfect question that I have about like use case. So like, one of the things that I think we go through when we go through life or just in crypto, right? Like human beings in like use cases are like kind of on a spectrum, right? Not only like an autistic retard spectrum, but like just like a spectrum of like being like, hey, this thing makes sense in terms of like application in this area. So what I mean by that is like there is a privacy aspect, there's a scalability aspect, there's a verifiability aspect for this. So you mentioned stablecoins, like that medium of fitting this technology use case for that makes sense. But like, how do you think about that then for this? Because verifying and privatizing in a way all of USDC's transactions such that there's mathematical proof for it, that's a huge scale versus that of like something that's smaller. So how do you guys approach that? Is it like bespoke for every single thing, or is it like, and is that how your technology stack is adaptable to these environments? Or is it like, no, we just think about the entire vertical and we build like a standard or researcher standard for that entire vertical that can be universally applied? How do you guys think about that?
Yeah, so we have like really a core primitive that we developed that is quite flexible and generic. We call it like a provable private hash map or oblivious hash map, like similar what you would use on Solidity. Like a lot of like stuff is uses this hash map for on-chain interactions, and we have built like this private verifiable version of it. Of course, like with this generic solution, you lose a bit of like optimization potential in specific verticals. But we are going like starting from there and then optimizing if needed. Like if, for example, in stablecoins, like you need to hit certain throughputs. So these new chains like Tempo, Arc, those are hitting like multiple thousand TPS. So at least like that's the goal. And they can like maybe tolerate a bit lower transaction throughput if it's private, because it's of huge value to them. So they would sacrifice a bit of the throughput actually for getting confidential payments. But like they won't accept like going down to 10 TPS, for example, then it wouldn't make any sense for them. So for this, like we have to really then focus our solution on the use case. And that's, what we did so far also with World in the identity space, and which got us to like scaling this up to now 17 million users.
Wow, that's amazing.
Yeah, and I don't think you need to apply this from day one onto the entire solution space, right? So if you start using our product in the context of stablecoin payments, you don't need to transition every payment to a private version of it. I think certain transfers, certain transactions are totally fine if they are still being public, but there are definitely some of those which I definitely wanna hide, and maybe also I'm okay with taking a bit longer to be executed. Because obviously privacy adds some overhead compared to public, but if I think it's a lot about UX and how we present this to the user in the end, and if they are aware, okay, make your transaction private, but you have to wait a few seconds longer than usual and explain this properly, I think it's totally fine.
Yeah, let's take like the salary. Like if you want to get paid on chain, you probably like you really don't care if it's like 2 or 3 seconds, because you get it each month or like each week. Like latency is an issue here.
Yeah. So, you've mentioned coSNARKs in the past, and I'm curious as far as the differentiation between SNARKs, standard SNARKs. Like, where does coSNARKs fit into the picture here?
Maybe before going more into detail, I think it's worth to explain what coSNARKs in general are. So coSNARKs, it's kind of the term we made up, but it's all based on a paper from Dan Bonnet, published in 2021 about collaborative SNARKs. So basically what this does is we can generate a SNARK in an MPC setting. So let's say multiple nodes come together and compute together collaboratively one single SNARK. The big advantage in here is if the SNARK computation involves some secret witness, none of these nodes actually learn the secret witness, because it's split amongst those nodes and everyone just gets let's say an encrypted share of the secret witness. And in the end, we get a SNARK which looks completely the same as this would be computed by a single client or a server. That's kind of the powerful tool we get with coSNARKs.
And like the witness, like it's looking very abstract, but like this is just the private data this goes into. This would be, for example, a transaction or any PII. That's like the witness.
I'd love for you to also, because me and my golden retriever brain, and there's a small percentage of the audience which are on the same IQ capacity as me, but explain the SNARK-STARK differentiation too before we go to the coSNARKs. Because I love the fact that you've explained this, that it's a collaborative approach, right? So it's a shared compute in general, but tell me the difference there. Why coSNARKs versus not coSTARKs or coClocks or anything else that's there?
Yeah, so there's this differentiation in CK only land, without MPC, between SNARKs and STARKs. So this is two different ways how to make a proof. And like the most important feature you should care about is like SNARKs need a trusted setup. So you have to perform some certain procedure, actually an MPC protocol, that you kind of initiate the parameters to make this secure. And so there is like different versions where you have the circuit dependent, which means like per program, you need this procedure, this key ceremony, which is called. And there are like certain proof systems where you only have to do this like once in a lifetime, basically. And STARKs get completely rid of that. You don't need this trusted setup ceremony anymore. And in addition, they are post-quantum secure. So this is the differentiation between those two STARKs and SNARKs.
So
the reason why...
I'm sorry, go ahead.
No, like the one, like for one level deeper, the main differentiation is like the one operates mostly on elliptic curve commitments. So this classical encryption stuff that we use on the internet today. The other ones is like hash-based commitments, which is like also used a lot, but like is more from the symmetric than the public key cryptography area.
So obviously there's a size differential between SNARKs and STARKs as well, right? So a SNARK approach would be like something like ZK Sync. A STARK approach would be like something like StarkNet or ZK Porter and stuff like that. So you mentioned your stablecoin usage, right? So obviously the verification fee, because it's smaller, the speed for a SNARK is just quicker. So is that the reason why you chose to think about like, hey, if we're going to really move the needle on this, let's think about applying coSNARKs rather than coSTARKs?
That's definitely one reason, but the true reason and why also the paper focused on SNARKs versus STARKs is a very opportunistic one. Like MPC and the basic primitives in SNARKs, elliptic curve based operations, go very well together. Like there is some homomorphic property that you can like leverage in elliptic curves, versus like in STARKs, you're using hash-based commitment scheme, and by design, hash functions like should be very hard to predict. So there is no homomorphic property you can leverage, and that's why they usually tend not to be fast in multi-party computation. That said, we are heavily looking into research how to mitigate this problem at first glance, how to do like STARKs and MPC. So like there's like active research going on how to make this faster. But you're right, like even from a non-MPC perspective, SNARKs have some very nice properties, especially if you're talking about on-chain context and verification costs and so on.
Yeah, thank you for clarifying that. I appreciate it.
Awesome. And then let's see, as far as taking a step back for a bit for our audience, what would you say are some of the current trade-offs between privacy and performance that you're trying to balance here? And how are you currently working to try to make encrypted compute more efficient?
Yeah, I think there are obviously trade-offs between privacy and performance. As said earlier, every computation which is run with CK or other technologies like MPC add certain overheads to your computation. Then I think it's just a decision you need to make. Is it worth to accepting this overhead, or am I fine with running this completely in public? The biggest overhead we see actually when we combine MPC and CK is coming from the CK itself. So CK itself adds already quite an overhead to all of our computations. The extra overhead added by MPC is not that large anymore. So, but we think it's still crucial for us to keep this CK component, because otherwise we would just run the MPC in off-chain context and wouldn't, lack all those integrity features we get from CK. And I think still it's kind of a challenge a lot of CK projects faces, that they add this overhead, not just in terms of costs, but also in terms of end-to-end times, which results in quite bad user experience. So if a user usually waits 3 seconds for a transaction to be processed and now has to wait 15 seconds because CK proof generation takes quite a time, then this is a burden a lot of users are not willing to accept. And so I think there needs still to be a lot of work to be done to get this to acceptable ranges and acceptable overheads.
Yeah, and maybe like from a raw engineering point or R&D point of view, like it was always the decision for us at Taceo, like, do we go like very early on, like when we started 2022, this like called virtual machine route. Back then, like RISC-0 was the only CKVM, and like we really liked what they did, and that like it was like just phenomenal idea to have like a virtual machine running on RISC-V instructions. You can just program Rust and get like a zero knowledge proof. Like this was just amazing. But ultimately, like we decided against it and said like we want to work with design partners to exactly mitigate these trade-offs and to really go for performance all the way and not for programmability first, because like at least what was our experience, like those partners valued performance way more than programmability because they had to get the use case live, and they don't have to get like general programmability solved. They wanted their use case solved, and performance was like, after security and privacy, the topmost priority.
The same goes for level of decentralization. So when we are talking about MPC, we usually have a certain set of nodes who run the MPC. And currently a free party setup is the most performant one. That's just the case. But of course, it is not that distributed as you may expect or wish for. But still, it's much better than just run this service in a centralized version, right? So even getting a free party setup gives decent decentralization, while also balancing kind of the performance aspect of it, because it's still kind of fast to run these computations.
So I guess this three-party setup is talking about this proof delegation thing with coSNARKs, right? So like, can you walk me through, you mentioned like World like earlier. So explain to me proof delegation in relation to coSNARKs and like how that system works with this methodology with like World, for example. It was like, one of the things that you guys put out this article, which was huge, and coSNARKs itself is like a big, huge innovation, right? Because it's like basically shared distributed cryptography, that you guys have moved the needle on like a big deal. But explain to me how that works with this proof delegation methodology with World, right? In this 3 people mechanism.
Right. So the proof delegation, the goal of proof delegation is that when a client needs to generate a CK proof, client side, because there is some secret witness involved. So let's say my date of birth, I want to prove that one, that I'm older than 18 years old. I need to compute this on my device locally, because if I want to outsource this computation, I need to trust some server with my date of birth. That's actually what we get rid of it using CK proofs here. So we often see that a lot of those devices are just limited in the resources they have. So this could end up in very, very long proof times when they run client side, or even to an extent that the proof cannot be computed at all because they run out of memory. So I'm not talking about those really simple proofs which just can be computed with modern hardware, but if we go into the direction of really large proofs or even combine multiple proofs together, then those clients are definitely at their limits. So for that, we introduced the proof delegation network, where a user can outsource this proof generation to this MPC free party setup. Each of the MPC nodes just get an encrypted share of my date of birth. And then they start collaboratively generating this SNARK for me, essentially. Once they're done, I get back the proof, or they directly post it on chain for verification reasons. So I can still use the same service, but I'm probably much faster. So improvement on the UX side of things, and keep up the same level of privacy.
So in your case, just to expand on this, like, so GDPR is like a huge thing, especially in Europe, right? In your part of the world, right? In America, we have a little bit more of like a pay to play kind of scenario for it. But like, I would say, so if you're looking at World, like they're taking my iris data, right? And so in a simple scenario, like with USDC, you said, like this coSNARK functionality would be like, okay, so I work for Taceo. I've already verified that my iris data is here. You would say that, hey, to pay out Ash for his work that he's done hypothetically on a monthly basis or whatever, that ZK proof is being pushed via that iris information that's there, combined into your third-party MPC stack. So you could say, this is verifiably Ash's address. Ash has been paid for this kind of services, and then you guys would remit a stable like payment or whatever functionality payment in relation to this case, right? That's how it's working, right? Because they have this data that's centralized around the iris, right? From that, it's going on chain to your MPC that's pushing on the 3. You've also said that this has also been done. So this compute network would allow to say, hey, we're verified. We paid this individual. We can verify that this is the individual. This is how we know that we can push this payment out.
Yep, it's in the Vault case. It's a bit different. Here we actually starting out by storing the iris data or the hashes of the iris scan already in MPC. So there's a three-party setup which actually stores all the data in a secret shared form. This is the way how MPC doing splitting up the data to multiple nodes, storing it there. And this is necessary because if the same user wants to sign up again with the iris scan, the system needs to check, okay, I already have seen this user, I already have seen these irises, and needs to reject the registration process. So for that, it's important that we keep this data around and be able to compute on this data again and again. And this is done in MPC, and this is, as you pointed out, GDPR is a big thing, especially with such kind of data, right? Because it's some form of sensitive data, obviously. And we run through this process also with data regulators to check if storing this data in a secret form in a three-party setup is still conflicting with GDPR rules or not. And we are glad to see that the result is, okay, this is not personal data anymore because it's anonymized and cannot really accessed by any one of those parties. Not World, none of the node operators in the MPC can access this data. And from there, we actually store basically a public key in an on-chain contract, which is owned by the user. So if I'm a World user and having the World app there, I sign up with my irises, and that when the sign up is successful, I can store my public key in this tree. And every time I want to interact with the World protocol and prove I'm a human, I can run an inclusion proof of this public Merkle tree and can show my public key is part of it, which means I'm a registered user. So that's how we combine here MPC and CK.
All right, let's see. To get into our next question, would love to hear a bit about where you see Taceo fitting into the competitive landscape with other privacy-focused projects, whether that's Aztec, Alio, Secret Network. Like, where do you think Taceo differentiates itself and fits into this privacy-focused project landscape?
Yeah. So we're the only one that really does verifiable encrypted compute. So you have folks like the Secret Network doing encrypted compute on trusted execution environments. You have like FAG companies that do encrypted compute, and you have like CK companies that do like private state, like CK only, which do not have the ability to like use that can use like input from multiple users, which most often in the internet, like you interacting with another user, maybe in the future another agent, but like there's like two parties, like if you want to abstract this, that want to work together or like find out something together. And so like we're really here the only one that does verifiable encrypted compute, which for blockchains we think like is just like necessary. Otherwise the encrypted compute layer is just an oracle, and why do you want to introduce for such important computation on Oracle?
Yeah, you mentioned a couple of L1s or L2s in the privacy space, I would say. In general, we see us more like we augment existing L1s or L2s with verifiable encrypted compute capabilities. So doesn't matter if it's now ATSTAC as a private state CK privacy chain or Ethereum as a public chain, we can integrate both networks quite rather easily, I would say, with this verifiable encrypted compute capabilities, because the only thing we need to integrate with those chains is a verifier of our proof we put on-chain. So we can run all these computations in an off-chain setting and just post the results back to the host chain with the proof we produced. And only upon successful proof verification on that chain, you can trigger the desired state transition, like payout funds or whatever. So in that sense, we can actually work together with any other chain out there. The only thing we need is a proof verifier in a smart contract.
How much are you seeing use, or do you envision use for Taceo's like approach towards, like, so you're using it for biometric data compliance, right? With GDPR, right? That's obviously World could be, that's one of the plays for doing, payments or anything, right? Purchasing and all this stuff. But in that same vein, we're talking about biometric data. I'm wondering, how much are you thinking about this in the ML and AI space on chain? Like, we've known that AI and crypto is this new huge vehicle. It's the new narrative that's there. Like, are you thinking about Taceo being applied for in that intersection of sorts?
Definitely. So we were thinking like a few years back, like we had the thesis that like proprietary data, like really this data that cannot be accessed by scraping the internet, like is really valuable and would get the models, especially in the verticals, much better. This thesis like was not really validated from the market in the last, let's say 2 to 4 years. Now this year, everybody's catching up with this, like, okay, this is the next thing we have to do to make the models better, because like we are running out of public training data. And like, if you like just create synthetic data, like this is still from the public data. So it's more of the same that doesn't really give you a lot, like at least not an order of magnitude better. And so I think we're seeing now slowly playing out this thesis that actually people that train the models want access to private data, and like there is a friction, and this friction can be solved through programmable cryptography, because you do not really use data ownership of your data, and you have like a very controllable way maybe even to sell your data. That said, like machine learning in itself, although it's like highly linear, which like we usually like in programmable cryptography, because like we have some tricks here to make this really fast, still the amount of computation needed to train an AI model is huge. Like you should know the stories that they buying like all this energy up that they can even train the model. Now, if we come here and say like, yeah, and now with our solution, you have to 10 to 50x like your energy consumption, they're like, this is not gonna possible. Like we are hitting the physical limit here. And so that's why like here is like really the feasibility, I think, the biggest issue right now. Where I see like a more like an easier go-to-market with like collaborative SNARKs is the agent side of things. So agents are much more lightweight. It's about inference, but actually like they will be the one that like transacting, for example, and they're using stable coins. They will like negotiate on behalf of us. Like maybe like for this podcast, we want to find like some like agree on a slot. And how do we do that? Easily would be like if all the agents of us would come together and exchange information about our calendars and just like book the slot that is most preferable to us. But I don't want to like tell you what I'm doing or not doing all the time. So there must be a sort of like way how to can I shield this information that my agent has from the agent from your agent. And that's exactly what like our technology can offer.
Very interesting stuff. I think as far as that calendar example you had given, I think all of us can appreciate a future where that is the case. But speaking a bit about as far as the growth within the Taceo ecosystem, I'm curious how you guys are trying to build a contributor developer network to incentivize the growth that Taceo is working towards.
Yeah, so we are quite close to the AdStack ecosystem. I think those guys doing a great job, especially on the Noir front. So this CK language. What we did is we took the Noir library as it is and made a MPC version out of it, which is called coNoir. So any Noir code you write today, you can take and just apply our library to it and have an MPC-fied version of your circuits, essentially. And that's what we've seen in the past is super exciting for CK developers, because they now have a tool to touch. If they are familiar with CK, they can now easily expand also to the NPC space, and which means the design space they can work on is much broader now, because as Lukas mentioned earlier, you can now not just work with a single user private state and prove some statements on that, but you can now start combining multiple user inputs into one aggregated group and run some computation on it and get a proof in the end out of it. That's what we've seen with some of the teams already picking up our library and building quite fascinating first prototypes and hackathon projects with it. And that's something we just want to continue and invite more people to play around with and get an understanding what they can actually do with MPC plus CK.
Yeah, maybe for those that don't know, like Noir is like the CK language everybody's gravitating towards. Like it's looks like Rust, so they don't have to learn a lot, but get the CK basically for free, and like they get the performance of having like a domain-specific language exactly for programmable cryptography. And now they got like Rust for CK basically for free, and through our adding coNoir, like this MPC part, they getting MPC, like another like superpower for them. And for us, it's like also win-win, as we can tap into like this most vibrant CK community that is out there, like with the most interesting builders. And so at hackathons, like they often run into problems that then can be solved with MPC, which they even didn't know before that they had these problems and how they would solve it. It's just like, then you can tell them, you can just use like this extension of the library and you're good.
Yeah, thank you for clarifying that, because when I think about privacy specific languages, I, think about Cairo right now, or I think about Leo, I think about Daml and all this other stuff that's there. But it's cool that it has this Rust like syntax that you did. And, this is kind of interesting itself that it's out there and people are able to use it. My obvious thing is to incentivize people to use something or, learn something new. The traditional modus operandi in crypto is token, right? I know it's kind of like the dirty word, but it's also like the necessary word. Are you thinking about a token incentive model for these developers to come on there and learn this, or for the compute network that you guys are planning on doing? Or is this no, you're thinking dude, much like the world thing, we want to focus on an enterprise utility thing that's there?
I would say in general, we definitely want to encourage people and builders to work with our stack, because we think this is a missing component in the on-chain ecosystem, and I would like to see more of these applications being built, because I think it's just helps all of us in getting further. I'm a bit cautious and in incentivizing with tokens, because then you also get I would say the quantity is quite high, but quality could suffer, right? We definitely want to work together with the best teams and the most ambitious and motivated teams out there. So far, we hope we can get their attention via our deck and just the kind of vision we hopefully commonly have. There are some conversations about token, yes or no, but definitely it will take some time to fully flesh this out. And I think for us right now, it's more important to actually show traction, to show this the feasibility of the things we're building, and with that as a backing, more details can be shared.
Maybe one bit we can share perspective on the token we have on Taceo. It's much more likely that a token for Taceo makes sense in the sense of a network token. So we're building this network. This has to be secured. we have to incentivize validator for an honest behavior. And so this is a classical sense where like a token, I think, has really makes sense, where you cannot substitute it like easily with some stablecoin or some other token. And the second thing is like we want to incentivize a certain behavior in the network, which we think like gets us really a huge network effect. Like we're thinking about like creating this private shared state, what we call like this is the state, there's secret shared on the app layer, for example. And if an app allows people to query its secret, like its private shared state, you have the same composability that you have today on Ethereum, like, which is like the main bottleneck now on, let's say, privacy chains, that they have like really siloed their data into private states, but you cannot really call it from another smart contract and so on. And that's what like made DeFi great, that you have these Lego bricks that you can just build around. And that's exactly what we want to also do for encrypted compute and incentivize exactly this type of behavior, because then we think like this will create the most economic value that like encrypted compute can have.
Very cool. Very cool. So thinking ahead as far as the future, I'm curious as far as some of the key milestones, metrics you guys are working towards, as we may or may not be working towards creating a token over the years ahead.
Yeah, I think like next weeks and months going to be quite exciting on our side. So we going to launch 2 new services in our network. One is based around primitive called OPRF. So basically what you can get with that is you can do a couple of things, but how we going to use it in the beginning is to generate nullifiers in a completely privacy preserving way, which going to be used in the world ecosystem at the beginning. And the other primitive we're building out, Lukas mentioned earlier, is this oblivious hash map, where you can actually store private data persistently, combine it with other data sources from multiple users, and guarantee that any read or write access to this data structure is completely oblivious. So none of the involved parties, none of the servers can actually learn anything about when this data is modified or accessed. And that's how we think going to be the core primitive we're going to use for this private shared state network, where hopefully at some day in the future, millions of super valuable data points and data sets are being stored in there.
Yeah, so like until the end of the year, like really the goal also like from a capacity point of view is like to bring this into hundreds of like, let's say, transactions. Sometimes like these are different computations that have to do with identity, but like really to a throughput of like 100 plus state updates per second. And then that we're like ready for like Q1, Q2, like to really have the throughput that is necessary for the stablecoin industry.
I know we touched on a lot of this core stuff about the coSNARKs and about Taceo and where we think we're going and the possibility of the token, right? But I would love to hear, when I ran into both of you guys, like Palo Alto and then in SF, I also had the opportunity of meeting your advisor. I'm curious to see how you guys met and Vic was like, dude, like, you were studying and then, how you guys met and we're like, dude, let's go launch this particular thing. Because I just think it's fascinating, the standard deviations in that, like the 6 degrees of Kevin Bacon in like starting things. So tell me that story if you don't mind me asking.
Yeah, sure. Like actually it was at like a very local, small crypto meetup. We were listening, like Lukas was speaking. He was speaking about DeFi back then. And at least I was like, not like too, let's say, open to the idea of DeFi back then. Like still had to be convinced that it makes sense and ask him a lot of like serious and I think like critical questions. And since then, like we have been keep been talking. And yeah, then maybe Lukas, you can share why you kind of wanted to work with cryptographers and
yeah. Crazy decision.
Yeah.
Yeah, at least turned out to be quite a good time so far. I mean, I've basically working in the blockchain space the last 11 years, and I've seen a lot of every time the same issue, right? So when I did married my wife, we did a prenup, but did not do it in a traditional way, but put it on chain. So we built one of the first, we called it smart wedding contracts, and it's legally sound. So we checked with our lawyers and notaries here in Austria. And the thing was, if we want to actually manage our assets between the two of us, we have to put it on chain and we need to make it public to everyone, which just sucks, right? You don't want to do that. So I realized, okay, we need some form of encryption. Later, when I was running my DeFi protocol, we implemented automated investment strategies. And again, the same issue. If we put on-chain very sophisticated strategies, everyone would just see them and would be able to copy them. So we need some form of encryption. And the third time I witnessed that one, when we were running our investment fund, we had to actually show everyone what's our asset under management, right? Because if you know our wallet, you can track everything what we're doing. And I realized over the last 10 years, the same issue was popping up over and over again. And then was super happy to finally meet those brilliant minds in my little town, right? So I was kind of surprised that those people exist here, and to see, okay, cryptography can solve all of these problems. And yeah, this was kind of the starting point. We're working together.
That's awesome. Also, that's the first time I've ever heard of a marriage and prenup contract ever being on chain. I think that's like wild. That's awesome. At the same time, that's like full transparency, but it also seems naturally how, yeah, to your point, like disclosure of assets and AU and running a fund, for example, with trading strategies or yield bearing strategies and keeping that open would naturally come to this point of cryptography. I'm guessing both of you are also might have known each other. Did you guys go to the same school? Were you guys, because your thesis advisor, when I met him, I was like, oh, holy cow. Like the other crazy story is, and I'm waiting for you guys. I can't wait. You should share this. Your thesis advisor is also part of Taceo, right? So I'm curious to see how that worked out too.
Yeah, so like I started my PhD in 2019 with Christian, and yeah, so I wasn't maybe his best PhD student, at least academic wise. But like I had like a lot of things going on, like some project, like was always a bit more interested in like the real world use cases and like how to get adoption for this technology. And he was basically looking for some years for some of his students to be like the guy that wants like to bring this into practice. So he was really encouraging us to like go this route, and then was also like courage enough like to say, okay, yeah, I want to do this not just like as a side hustle, like I'm really gonna fall in there and do the whole startup thing. And yeah, I had to quit my PhD, like there was no chance to finish it. Maybe like in 10 years I can go back and ask him to continue.
That's awesome. Yeah,
And
Christian's in chat. Sorry, go ahead, Lucas.
No, I think I want to say the same thing as you. I think it's super helpful to have such an experienced co-founder on board, which has really great reputation in the cryptography space, and yeah, is now really leading us in a sense of where cryptography and our research side of things need to evolve, so that we're not just have a great product now in the next 6 months, but also in 3 to 5 years, because that's this work he's doing now is actually contributing to that long-term vision of Taceo. And this is super helpful to have such a visionary guy on board.
Yeah, I think like what you get, like at least a good scientists and researchers, is like to think about the future. It's like, what could you do if like you have had a lot of money? Like what is just a money problem and what is like real limitation? And then he tells you just like to get this money, and all the other things like are not really a problem anymore.
Very cool. Very cool. Let's see. As far as final questions for you guys, would love to hear what you guys see as some of the biggest challenges you have ahead of you, whether that's the technology, the developer education, broader ecosystem alignment, working with these various regulators. I mean, what are some of the issues that you guys have your eyes on over the coming years ahead?
I would say, I mean, definitely depends on who you're asking on the team. But at least since I'm not the technical lead, I can keep away all those challenges ahead in terms of feasibility and performance and all this stuff, which are definitely big challenges. But yeah, from my perspective, more from a product lens, I would say mapping this powerful technical solution we have to actual customer and market needs, and translate it and tell it in a way that people feel like, okay, yeah, that's actually my problem and I want to have your solution. And that won't work out with telling them MPC, coSNARK, private chat state stuff. We really need to speak their language and understand their needs and map this together. I think that's still a challenge, but I think we're also progressing quite well on that end.
Yeah. For me, like it's more channeled like time to market. So I see now this really opportunity to change how we like use data on the internet and also like with blockchains, how we do finance. And in both cases, like there is like a pressure to get things done. And so I don't want to end up like that we're building TradFi on somewhat more sophisticated rails, but with like basically the same properties and maybe a bit lower fees, but that's all we get out of this. And at the same time, like AI accelerating that fast, like our technology has to catch up like to like also manage the AI tasks. Because if we just like have programmable cryptography for everything except AI, this will be nothing in 5 years. Like there will be not much left. And so the impact that we can have on society is then very limited. So, but yeah, I guess this is like with all the founders, you always think you're too late to the party.
Yeah, I mean, trying to stay ahead of the curve. I know the exponential nature of AI is so hard to try to navigate moving forward and what those potential use cases will be, whether that's, with, millions or billions of AI agents and, the not too distant future. So it's great to hear you guys are thinking about that and, definitely trying to stay ahead of the curve as well as you can. Well, Ash, do you have any final questions? We'd love to chat with the team.
No, not at this moment. I mean, I think this was a good dive into Taceo and you guys as founders and like seeing how you guys met and the team. I would love for you guys to come back on in the future again as you guys hit some of those milestones or getting close to that maybe token point and hearing what you guys are doing, right? Because it's like an ongoing discovery. All of us are like either founders or going to be founders, right? Like, and it's just good to see how these projects like project and then as they evolve and what they do. When I met Lukas, like, I think like 2-3 years back, like going for runs with him, around Stanford's campus, like Taceo is like in a different state to where it is today and see it evolve and naturally grow. It's amazing. So I would love to see have you guys come back on and then tell us like about the new cool stuff that's there. And, also whether some of the theses actually hold, right? And like your go-to-market in terms of like what's happening, the incentivization of your own enterprise network that's there. Is there a shift in it? Like this would be amazing. But other than that, like, dude, this has been awesome. I just want to say thank you guys for coming up here and then, sharing your knowledge with the world. And also your innovation, your contribution to programmable cryptography. I do agree with you 100%. The modularity of, programmized compute as far as security is concerned is a huge aspect that needs to happen. And that's one of the things that make DeFi very successful, right? The modularity is essential for taking data and moving it across different pipelines and verifying things. So I think this is fucking awesome, for lack of a better word.
Perfect.
Awesome, guys. Yeah, thanks for having us. And definitely love to come back at some point in the future. And then comparing our statements of today with those next time. So let's see how it plays out.
Yeah, next time we'll visit you in Austin, like we do it in your podcast studio. That would be great. and going for an actual run because Stanford was not really running. That was jogging.
Yeah, that's right. That is right. That was jogging. Yes. Luckily now I'm a little bit better shape than when I was then running around with you then. But like, yes, both those stand. And I don't know how much, hopefully we'll do the run before we do the podcast, because friends of the pod is Tequila 512. And if we drink too many tequilas at Branch Waters, it might be really hard to do the jog, let alone just to run. It might just be a walk. But like, yeah, this is awesome, guys. Thank you.
Yeah, it was awesome.
Thanks, guys.